I left the bearing carrier and the shaft out of the SolidWorks design. We have stayed with the 90 millimeter, at least I believe it was. Let's see, we switched over. Let's go back to millimeters, grams, and seconds. So 90 millimeters through, that would be kind of our maximum. And while we're making some of these decisions, I know that I want to have at least 2 bearings to carry this. This is going to, we already decided that the cam at 2 kilograms, unless we lighten that or do something with it, if we stay with a steel cam section, then it's going to be quite a bit of rotating mass. So 1 bearing without kind of the counter support on the backside of the housing doesn't seem like it's going to be very effective. So I'm going to take and remove the boss. So on the shaft, it wouldn't bother me to leave a little bit of a step. And on the other end, so that it doesn't slide back and forth, we're going to need some kind of jam nut or lock nut to hold it in place. Once those are taken care of, then the motor that drives this, whether it's a pulley, pulleys would have a tendency to slip, but if we went direct drive with, I think we said a NEMA 23 frame, come up with RPM for a DC or an AC unit, then we're going to need some kind of coupler so that the motor isn't taking all of the load starting and stopping. Or if the some worst case happens and something jams up and it comes to a sudden stop, there is some compliance before it completely binds up. All right, so that's kind of on the shopping list of things to look for is the coupler, and when we're going through the design for the shaft, getting that in place. So our diameter for the bearing was 17 millimeters through, and we saw that the shaft was 16, so this is going to need some refinement also. Alright, so I'm going to open up a metric part, and again my template was updated to 2019, so it's going to bark at me each time I do that. Alright, so I'd like to minimize this housing, and one of the ways that we can do that is to look at it from the standpoint of a revolve. And so making an infinite length line, then I know at least some portion of this. And then we'll have the bearing face and then another bearing face. And then some wall thickness. And then a flange thickness of probably, well, we had 15 millimeters, so if I split that 7 and 8, 7.5, 7.5, I don't know that it really matters, but it gives me something that when I revolve, I will probably be in the ballpark on that geometry. So the face width was 10 millimeters, so that'll give me some starting. The shaft going through was 17 millimeters, so if I were to go 19 millimeters, that would provide a little bit of clearance, but I wouldn't be going too crazy with boring that out. All right, so this being a cylindrical part, we have a couple of ways to manage it. We can look at this from the total indicator runout. We could look at it from a positional and be able to manage some of those geometries. All right, so 40 millimeters for the bearing, and then 10 millimeters. So since it stayed in diametral, we'll switch over, go to 10 millimeters. And again, I may want to probably not so much if this is the flange side, not so much over here, but at least on the front, I may want to shorten that up a little bit. Have a little bit of the bearing exposed. Got a midpoint there. Have a little bit of the bearing exposed so that the shaft, or if we include the geometry in the shaft, then I'm not as concerned as as I thought I was. So we're going to bring those over collinear. And we'll go ahead and build in, let's just go 8 millimeter. And then I need an overall length. Well, 2 inches. I don't know, we're going to carry, so, right around 50 millimeters. I would think 75 millimeters would be a good starting point. I'll have to look at it from the geometry side. Okay, so everything moves as a group, so that's a good sign. I'm going to orient this to the origin by making it coincident. So the vertical line in the origin, bring that in. We need enough of a distance to mount our 6 millimeter, and so if I left 8 millimeters, I should be in pretty good shape for the flange. And then 6 millimeters to the outside. Alright, so let's see what that adds up to for our material. So I'll put in a couple of reference dimensions. So 68, that's still a pretty good size piece of steel to turn down and have to create all of these geometries. So I don't know that there's going to be much in the way that I can do. My design specification is that the cam will be sitting over here, the bearing will be sitting in here, the shaft goes through, butts up against. The cam will slide on the keyway and the shaft at the end. We'll have about 1 millimeter of clearance, which maybe it doesn't need that much. If we went down to 18, that doesn't save a whole lot. Mainly from the 40 to the diameter, and it probably makes it, well, weight's not an issue, so it would come back to the 6 millimeter, going 5 millimeter. Alright, so still a little over, let's see, 2 inches at 50 millimeters, another 16. Was it at inch and 5/8? So if we started with an 1 3/4 inch piece of material, so this would be a good time since I'm having to convert. Doing numbers in my head is always going to be fraught with its own dangers. So let's go ahead and split up. Yep, 2 and 2.6, not 1.6. All right, so still a pretty good chunk of material. We'd want to check the flange. I'm thinking threaded holes, and then we could assemble from the back side. All right, so let's go ahead and revolve this. And I did the extrude, force to have it. Let's go revolve 360 degrees, and that will set our piece. So the mating surface, we would be on the face to face going in, and then the concentricy, or the position, would be on the outer face. So we would need run out between this geometry. We could have clearance to the outer board, but then the center line for the 2 bearings would be needed to relate to that geometry. So as long as we can pick up at least some combination of those sizes, we'll be in pretty good shape. So I'll go ahead and do a save as the bearing housing. And then let's go ahead and see what we get for a metric thread. So jumped into the sketch a little too quick. I would like to do that with the hole wizard. So pre-selecting the face puts me into that selection. If I haven't pre-selected it, then it'll ask me for the 3D sketch or to select the face at that time. So instead of going into the 3D sketch, make sure that you pick your geometry if you haven't given it something already to sketch on. And we're going to go with an M6 by 1. I should be able to, 4 would probably be enough. So that being the case, still we have a pretty good distance, so I'll bring it up to 6. Alright, so we're going to set those vertical. I need a base circle. I can visualize it better with the base circle, so for construction. And then we'll set a dimension. So 58, just to see what that gets us. And then our circular sketch pattern. Through those, the thing to watch out for here is that it's also going to put that point right at the center. And so 6 equally spaced, and we'll go ahead and accept. And then notice that you have the preview for a 7th until I hit delete after making the selection. Alright, so that's going to cause me to need to add relations. So if I drag that point out and away and then bring it back until I get coincident, that will bring it into being fully defined. Alright, so I think we're pretty good, minus maybe an edge break or two, but we'll have to get the bearing in there, see what it looks like. So on the housing side, we now have a distance, and so 66 millimeters. So in the base, oh, and this was the assembly, so let's see if it automatically opened. Nope, so that would be, we need to get the multi-body part open, because all of the changes take place here and then migrate into the assembly that we created as an external feature. Alright, so now I can identify the geometry that I created. And we'll go from 90 to 66. So that was one of the reasons that I wasn't really worried about the gusset having too much interference there. Let's see, I'd like to keep those geometries together, so I'm going to roll back. Again, I don't want to suppress the save bodies because all of the names, everything that was up here gets basically gets reset. Oh, and then I think, yep, I didn't get a measurement on that, so I did the outside at 66, but I need clearance for the inside, so 50. So actually the through hole should be the 55, and then that would be the 66. Okay, so let me accept that one. We'll go back into the sketch and you do a quick double check again. So it was 50 millimeters. I'm not sure where I got the 55 from. Alright, so for a little bit of clearance, if I gave it 50.5 millimeters, that'll give it about 10 thousandths per side. Again, this is not the locating structure. It could be, maybe for support, but we're going to have to look at that stack up, that if this flange is sitting here, then all of the load goes through the transfer. Maybe we tighten that up just a little bit on the clearances. The other thing would be to design it line to line and let the tolerances and the stack ups take care of them themselves when we get over to actually applying the dimensions. So that being the case, jumping around a little bit here, thinking about how this is going to play out. Alright, so we'll leave it at the 50 and we'll call it a line to line. And then we have the 66, and then that's going to get, and jumped into the extrude again, extrude cut. Let's go, I think I said 8 millimeters. Go ahead and accept it. And then on this side, we're going to have, let's see, do I want to do that as a whole wizard? Yeah, I don't see that one really taking off or being changing over to flatheads or to another style of screw. Maybe hex. We're pretty tight for hex, so I'm going to stay with the socketed cap screws. Alright, and then double check, since I'm working off of a memory, what I told it. And 58. So this is kind of one of the processes that I do when I'm working bottom up or even transferring back and forth to make sure that these dimensions are carrying across. And then advantage of the multi-body and the top-down assembly will be that, you know, a lot of that information is going to be present when we're making these cuts. So 6.5, well, it's going to be pretty close. And vertical. So I'm going to pause for a second and go check the geometry. Okay, so I found my listing in the Machinery's Handbook, an M6x1, 6 millimeter body diameter, head diameter of 10. So I missed that one by a little bit. So let's check it in the housing. Oh, that's in the rollback. So make sure I'm getting into the to the base. All right, so we'll have to check that, and I'll make that a 4 construction, and then we'll go 10 millimeters, so right on the edge. So the 58 to clear, and then so if that were to go up to 62, and I have a little bit of clearance to work around the head. So if I needed to know what those are, or what that clearance is, I can hold down the shift button and go between the two, and I have about a millimeter. Alright, so that's pretty decent number. And so we will go into the circular sketch pattern, and notice it jumps over to the origin again. So instead of the origin as a point, I'm going to come back over to the center of the circle, and we'll give it the 6 holes on the pattern, and we'll go ahead and see what that looks like. Alright, so same thing, if I drag it away and bring it back until it goes coincident, then those should go fully defined. Alright, so features, extrude cut, and then we'll go through all. Alright, so that gives me the face and the 10 millimeters. So let's see what that does to the housing. So we'll double check my attention span here, and I said 62. As we rebuild those, then on the revolve, we need to come out just a little bit more since we had 10 millimeters. Let's see if 11 looks like it's going to be in decent size. Alright, so one of the things we can do from the sketch is I can come back with that same 10 millimeter bolt head, and I just want to see what it looks like on the flange side. So pretty much even, right even with the edge. Now that would be a problem if we were going to use a washer. I'm not planning on washers here. I need the clearance, but I really don't have any head clearance back to the flange if this ends up undersize. So that would be a consideration of maybe making it a little bit bigger. So let's go ahead and accept that one and see what we ended up with on a nominal. So 2835.72. So 12 millimeters on the flange it is. And even though we're starting off with a 3-inch chunk of steel, we're not removing as much material, but we have a lot to remove, and a lot to remove through the centers, and then bringing it around and getting the other bearing on position. So, all right. So trying to minimize the manufacturing, but at some point we have to make the decision and call it good. So. Go back to the 50, right, and then the clearance. Oh, next one up. All right. Okay, so that gives me a flange housing and a place to hold the bearings. So I'm going to roll to the end, make sure everything stayed named correctly. So all of my names are still there. I didn't lose any links. Still have the save bodies, and we'll go ahead and save. And I'm ready to create a top level assembly. So double check. Nope, didn't go in. All right, so I want the base, and I'm okay with it at that angle. So origin to origin by accepting the check mark. And apparently that one did not update yet. So let's go grab the assembly, let it update, make sure everything comes across, and we'll save that. All right, so quick double check that everything transitioned. And then we're going to save. And we'll stay in my follower, so cam follower. And we could put assembly, but I usually just the SLD ASM on the back side of it's good enough. Alright, so I'm going to insert a component, bring in the bearing housing, and we have our contacts. Alright, so those will go coincident. And then the two faces can go concentric. And then for rotation, we'll just make sure that I have alignment. Alright, so if any one of those misaligns, then I would have a chance to correct for the geometry. Alright, so one of the things with the bearings then, since we're at that point, is we're going to go back to our download and did something either really wrong or I pulled, nope, that one's fairly small, so that must be the follower. Alright, so let's undo that one, make sure it didn't lose anything by rotating. And then we'll try one more time. So let's see if it, nope, didn't pull up configuration. Alright, so I think we were going to decide, because the standard bearing didn't have, I think, the 10 millimeter depth. Alright, so I'm going to pause and go find that bearing, and then we'll be back. Okay, so I'm out at the McMaster site. I grabbed the permanently lubricated ball bearings. 17 millimeter shaft, 40 millimeter, and then that was the issue, was a 12 millimeter width. All right, so all of the loads, it looks like it would maintain, but I just hate to think of that thing. Well, it's not going to make it to 10.5, but I hate to think of that thing rotating that fast without some counter support. All right, so that should have gone to my my downloads. While I'm looking at this, let's go over to see if I can get back to, I think it was, check my notes here. Alright, so I gotta go back to the bearing information. Alright, so pulled up the Machinery's Handbook roller, ball and roller bearings. We're between 10 and 18 inch basic bore diameter. And so let's see, this is showing needle. Double check here, raceway housing, needle roller, drawn cup, inner ring. Maybe that's not it. I think I've located the chart that I need. Alright, so we have the bore diameter. We're between 10 and 18, so that'll give us a our G and our H class of fit for the clearances. And then for the housing, we are in numbers in inch, so 4/10 of a thousandth to 1 thou and 3/10, basically between the 30 and 50 millimeter. All right. Also, if we go back over to look at the specification from the manufacturer, the ID tolerance minus 0.007 millimeters. So have to do the conversion on that one. And the OD tolerance minus 0.01, which would be right around 4 thousandths to 0, to be right on size. All right, so based on that, I'm going to go back into the housing, and the information that I needed was in the revolve, and so could go back and set both of these to be equal, but I'm still not entirely sure that we won't see something later on where I'm going to want one of these to be a little bit larger. Alright, so if I look at that in section view, have kind of probably the weakest cross section is going to be right here at the flange, and so having that contact and then contact to the face, maybe this outside surface is the least critical, and it'll be between those two pieces of geometry. So my section view, I'll turn the section view off and save it, and then we'll see if I manage to grab the correct bearing. Alright, so I'm kind of doing a running tally as I'm going through this of picking the items. Alright, that one looks a little closer to size. Verifying the specifications against what standards are available, Machinery's Handbook or the engineering handbooks. Set the mate. Okay, and that one got a little pressed, so it would be the flange side to the face. Alright, and then because of rotation, if we go back to the concentric, there is a checkbox in the mate to tell it to lock rotation. Alright, and then that little closed-in section shows up. Alright, so same thing. We'll go face to face. Not sure why that's showing up now, but okay. I may have to point that somewhere else. Alright, coincident. Oh, and I jumped over the concentric again. So concentric, lock rotation. Notice that it fills the center section, and mainly that's so that we're not dealing with any other rotation. So that gives me a pretty good sense of what I'm doing for the housing. And we can still go back and adjust based on the lengths. So let's see, what did we have? Actually, it was a little shorter. We have a dimension, so 30, 15, and about 5 on the outside. If I put that into the flange, well, that's only about 45 millimeters, so we're closer. Well, that's going to come back to, yeah, we can open from there. Take one more look and just see if I'm satisfied with the 75 millimeters. See what 50 millimeters looks like. And jump back into that section view. Yeah. Alright, I think that's still a pretty decent carrier. And I don't have as much coming out the back side of the part. That should update. Alright, and then one quick check from the front plane. We'll go into the section view. Just kind of see what the clearances on the bearing might be. Usually this inside section, so that being the case, I may need a little bit of a spot face to clear that inner that ID for rotation. Alright, I would still like to keep that that small. I don't know that I need to open that up all of the way, but that gives me something else for the list to check.